Hello, ELT 132. This is Roger Young, and this weekly activity is going to discuss latches, this specific video. So, a latch, the symbol of a latch anyway, is shown right here in the upper left corner, okay? You have two inputs, and one is called S, and one is called R, and you have two outputs. One is Q and one is Q bar. Sometimes I refer to Q bar as Q naught. Alright? So this right here is your symbol for a latch. Now, let's look at the actual function of this latch. In this case, we're looking at an active high latch. So if they're both 0, Q and Q bar, they don't change from their prior condition. So nothing's happening basically, all right? Now in this case, when R turns to a 1, right? You put a pulse with a 1 there, reset input is active. In that case, Q drops to low and Q bar goes to high. These two are opposite of each other, right? So and further, I'm just going to talk about Q. I'm not going to talk about Q bar, but just realize if Q is high, Q bar is low. If Q is low, Q bar is high. So in the reset condition, Q is low. Now, the next condition we have is when S is high and R is low. In other words, when your set is high, that's what the S stands for, set, and reset is low, that's what the R stands for, is reset. In this case, Q is high. Finally, the other third condition, which you do not want to see, it's forbidden, is when both are 1, and you'll see why shortly. Now if we look at the timing diagrams over here, you're going to see that if they start out with Q low and Q not high, this is in the reset state, all right, reset condition. When you get a positive pulse on this S input, Q is going to go high and Q bar will go low, obviously. This is in the set state. So if you're asked if your latch is set or if it's in reset, you can tell just by looking at the value of your Q output, right? Now, later we get a pulse on the reset input, the R input. And when that occurs, Q goes from high to low. This state is the reset state. Q is low, and obviously Q bar is high. And then the same thing happens over here that happened in the beginning. We get a pulse on the set input, and in that case Q goes high and Q bar goes low. Now let's take this one step further. In the timing diagram below, we start out the same way. Q is low, which means it's in reset, and we get a pulse on the S input, the set input, right? This causes Q to go high and Q bar to go low. So now we're in the set state. And what happens? We have another pulse on the set input and another pulse, but nothing changes on your output. Well, think about it. We're already in the set state. There's nothing for it to do. It's like turning something off and keep pushing the switch down. I mean, it's already down. If a light switch is up or down and it's down, you keep pushing it down, you're not going to change anything because it's already off. Well, in this case, it's in the set state. So no matter how many times you pulse that set input, you're not going to change it because it's already set. Now what happens here? We get a pulse on the reset input. This causes the Q input to go low. So now we're in the reset state. What happened here? We got another reset pulse. Another reset pulse. Did anything change? No. It's the same behavior as you exhibited and observed here. Once it's in the reset state, you can reset it as many times as you want. It's not going to change the output to Q. And finally, then we have obviously a set input right up here. This causes your Q output to go high, so now you're in the set state, and then you're going to have a pulse on your reset input, which causes Q to go low, which means you're in your reset state. So this basically is all there is to how a latch functions. And this is your SR latch without any steering gates. Next, we're going to talk about a latch with steering gates. Thanks for watching.